Hello and welcome to problem 414. So 414 is more or less a tedious hell of calculation. So we're not even going to do the whole reading the exercise part. We're just going to start calculating and go through everything from the beginning to the end. So we consider a joint distribution for claim numbers n1 and n2 looking as such, where this is n1 going down and this is n2 going to the side. And then they say, well, what are the marginal distributions of n1 and n2? And what are the mean values of n1 and n2? So let's just recall that the probability that n1 is equal to, for example, 0 is given as the probability that n1 is 0 and n2 is 0, plus the probability that n1 is 0 and n2 is 1, plus the probability that n1 is 0 and n2 is 2, right? So whenever we want to find the marginal distributions, for example, if I want to find the probability that n1 is 0, I just take a look at all the cases where it can be 0 and I sum up the probabilities. For example, if I want to see the probability that n2 is 1, I just sum up all the probabilities here for the case that n1 is 0, n1 is 1, and n1 is 2. So the marginal distributions are quite easy to find, and what we actually see is if we kind of notice what's going on in this thing here, this is 0.8, and then I have 0.06, 0.06, and then 0.05, 0.05, 0.01, 0.01, and so on. What we actually see is that n1 and n2 have the same distributions. So n1 and n2 have same distributions. Since the table is symmetrical. So more or less, it's enough if I just find the marginal distribution for either n1 or n2. Because, for example, the probability that n1 is 0 is the sum of these three numbers, whereas the probability that n2 is 0 is the sum of these three numbers. And it's actually the same three numbers because the table is symmetric. So what I've done here is I've kind of prepared an Excel file here where I have copied the table into this Excel file, and the marginals, so this is the probability that n1 is equal to n, where what we have here is n equals 0, 1, 2. And the way we do this is just by summing the rows or the columns. Again, it doesn't make a difference because the table is symmetrical. So this is the marginal distribution of n1 and also the marginal distribution of n2. So you can just check your results up against this. And the next thing we want to do is to find the mean of n1. Now recall that the mean value of a stochastic variable that is discrete is given as the probability of that stochastic variable attaining any value multiplied by that value. So it's the weighted sum of all the values that it can attain. So we don't take the 0 value because the probability of n1 equals 0 multiplied by 0, that's just 0. So we take the probability that n1 is equal to 1 multiplied by the probability that n1 is equal to 2 multiplied by 2. So there is also 1 multiplied on here, but that's just invisible. So the mean value of n1 is given by this. And we can find it because we have the marginal distribution here. So the mean value of n1 is just this multiplied this, plus this multiplied this, plus this multiplied by this. And in fact, I don't need the first term because that just gives me 0. So this mean value of n1 is equal to 0.155, both for n1 and n2, actually. So I can just add these two are equal since they have the same distribution. Okay, so that was part A. Let's go on to part B. We are asked, are N1 and N2 independent? So if N1 and N2 are independent, then we would have that their joint distribution. So the probability that N1 is equal to one value and that N2 is equal to another value is equal to the probability of their marginals. So if they're independent, then we would be able to do this, right? For all N1 and N2. However, we note just quite simply that the probability that N1 is equal to 0 and that N2 is also equal to 0 is definitely not equal to the product of these two probabilities. And we can just check that in Excel. So what we can note is that the joint probability here is 0.8. However, if I take the probability that N1 is equal to 0 and multiply by the probability that N2 is equal to 0, then I get 0.765. So since 0.8 is different from 0.765, so hence N1 and N2 are not independent. Great. So that was A and B. In the next video, we will solve the rest of the exercise. It's not a very hard exercise. We just need to do loads and loads of calculations. So see you in the next video.